There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, redenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hi, I'm Pie Guy Pepin, and this is the 2-dice puzzle. Now, I asked a bunch of third graders that they thought would come up, and some said 2, some said 12, some said that this would come up, some said this would come up. And there was really no consensus that they would both have the same thing, but they just did, but I didn't roll them. That one bounced off that one. That one rolled too far. That one hit that one, so...
You could just bring them in.
Well, I'll just bring this one in, which was 1, so I mark it in the 5-1 column. So we'll just put a bunch of them and put them on Excel and see which one of the third graders will write. But we didn't really have their names, so... Oh, 2 5s. Okay, I did it 10 times, and some of them we got twice. And the whole top row was nearly done. One of them we got twice instead of getting the next one. Then another one we got twice. And then one wasn't in the top row and it wasn't twice. So that's what I did.
Okay, everyone. Again, we had a purple die and an orange die. And here are the 36 possible arrangements that we could get. 6 times 6 is 36. If you had 1 and 1, it would be 2. All right? If you had 1 and 2, it would be 3, and so forth. Now, if you look at this carefully...
But the question is, why is it mostly 7?
Okay.
It's mostly 7.
Okay, well, when we look at 7, we've got 1, 2, 3, 4, 5, 6 different arrangements that can give you 7. 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. On the other hand, there's only one arrangement that can give you 2. There's only one way to get 2, 1 and 1. There's no other numbers that will add up to 2, but 1 and 1. But as far as 3, you can get 2 and 1. You can get 1 and 2. So there's 2 arrangements for 3. It reaches a maximum at 7.
Yeah.
And then it starts going down again. So if you had to bet on a number that would come up, the most probable number is 7. And there's 6 different out of 36. 6 out of 36, or 1/6 of the time, theoretically, your probability is 1 in 6. You should get 7. Now, will you get 7 most of the time? No. Only 1 out of 36 on average. When you talk about large numbers, on average, you'll find, and we'll show you this in the next clip of the video, you'll find that 7 is the one that comes up the most. But with 10 or 20 or even 36, you're not guaranteed that you're going to have more 7s than any other number.
Hi, welcome back. This is a special 3 episode one, and this is our third one, the simulation.
Okay, this is a simulation of what happens when you roll 2 dice. And here we have the possible values you can get. This is the 2 through 12. 1/6 of the time you'll get 2, 2, 6, 3, etc. And this is a bar graph showing the expected values, assuming that you threw the dice 1,800 times and it gave you the expected values. Now right here I have, using Excel, a simulation. This column goes down 1,800 values, and dice 1, dice 2, dice A, dice B, and the sum. And over here I have a actual bar graph of the results, and here I have the frequencies. All right, so every time I hit F9, you'll see that it changes. But usually, if you look at the 7 comes up as the highest, but not always. We'll do it until it doesn't. There, the 8 came up higher than 7. All right, even with a large number like 1,800. So this is a nice little fun exercise you can do using Excel to show that the actual throwing of the dice, or at least through a simulation, gives you pretty much close to what you expect theoretically. Not exactly, but you only get this good agreement between the actual and the theoretical when you use large numbers.